Hi, thank you. So before I get started, I'm recovering from a cold, so I may cough a little bit here and there. So please bear with me on that. So my name is Ethan Jackson. I'm a graduate student at UC Berkeley. I'm Scott Schenker's student. And before coming to Berkeley, I spent 5 years in industry working on software-defined networks, specifically a project called Open vSwitch. And during that time, I got to see a lot of people struggle to deploy and manage distributed systems. So this project I'm going to talk about today, Quilt, we hope addresses some of those challenges. But before I get into that, first let me make a point about software-defined networks that I think is important. What really made SDN a big deal was that it finally gave the network an API. And the network was the last piece of our infrastructure that was missing a really good API. So we're in this regime now where we manage our infrastructure by making API calls instead of by moving around sheet metal. So we've got APIs for managing compute, from cloud provider APIs to more modern container orchestrators, and APIs for managing the network, SDNs, network virtualization systems. So if you're trying to deploy a distributed system like Spark, this is perhaps a bit of a caricature, but the task comes down to these 3 steps, right? You choose a compute API, usually the API your cloud provider exports. You choose a network API, usually the API your cloud provider exports. And then you write a deployment script that understands those APIs, the system you're trying to boot, and manipulates the APIs appropriately. And this is a massive advance over what we had before, right? It's much better than moving around sheet metal. But I'm going to argue today that this problem is not solved. I'm going to argue it with an example that should be familiar to many people in this room, the Spark ec2.py script. So this is a script from the Spark repo. It was the official script for booting Spark until it was removed from the repo for mysterious reasons. It's 1,500 lines of code, and in my professional opinion, as a graduate student, it is utterly incomprehensible. It is difficult to understand. And the complexity of these scripts causes problems, right? So 2 example problems. First, network security. Traditionally, we secure our networks by deploying a firewall that sits in between the public internet and our system, but everything behind that firewall has unfettered access to everything else. But in a world of software-defined networks, we really could do fine-grained control of east-west traffic behind our firewalls, but we don't because setting up the necessary ACLs in this deployment script is too difficult. And the second problem, which I would argue is a little bit more fundamental, is one of portability. So if you'll remember, the script is called Spark ec2.py. Right? If you'd like to move to Azure, if you'd like to move on-prem, if you'd like to move to Google Cloud, good luck. You're basically going to have to rewrite the script from scratch. So we're hoping to address the problems that deployment scripts present by developing a new system. And that system's called Quilt. It's an automated deployment system. And it's based around the idea, that's fairly simple, that we should write down what our application looks like. Right? So we're going to write down what our application looks like in a new specification language called Stitch. Stitch is a Lisp dialect, and it allows you to declare the application you'd like to deploy and the infrastructure you'd like to deploy it on. And then given these 2 specifications, Quilt can automatically deploy it for you. So this is easiest to describe with an example, so I'm going to walk through a motivating example. So we're going to deploy a complex multi-tier WordPress instance. We've got HA proxy for load balancing, a configurable number of WordPress application servers, MySQL for a database, of course Apache Spark for data analytics, and we're going to run Spark in multi-master mode, so we'll have Zookeeper for leader election. So an operator wishing to deploy this system would write the following Stitch specification. So Stitch is a Lisp, so for those of you who aren't familiar with Lisp, the basic rule of thumb is whenever you see an open paren, the next keyword is the name of a function, and then following keywords are arguments to that function. So in line 1 through 6, we're importing Stitch specifications for the various subsystems that we would run. We're assuming these would be written by sort of developers of those systems. In the early days of the project, that means me, personally. In line 8 through 12, each of these specifications we imported exports a function called new. The new function, when called, generates the subsystem and then returns it. And we're going to store that subsystem in a variable. So in line 8, we call mysql.new to generate a MySQL tier, stored in the variable db. In line 10, we call wordpress.new to generate a WordPress tier. WordPress depends on a database and memcached, so we pass those in as arguments to the function, and we store that in WP. And then in lines 14 through 16, we connect Spark to the database and the public internet to the HA proxy. So this is the spec that an operator would write. Let's zoom into the spec that the developer of a system would write. So let's have a look at this wordpress.new call. So the code for it looks like this. Line 1, we say we're declaring a function. It's called new. It takes 4 arguments: the name of the tier, the number of WordPress instances to create, sorry, a database tier and a memcached tier. In lines 2 through 4, we declare our WordPress instances and give each of them a label. In line 5, we configure them. This just means we set up environment variables telling them the host names of their dependencies. And then in lines 6 through 8, we connect them to their dependencies. So in line 8, for example, we say WordPress is allowed to initiate connections to memcached on port 11211. And then finally in line 9, we return WordPress. So given this stitch specification, when you pass it to Quilt, it's going to execute it and generate something like this. So this is a graph generated from this stitch specification. Each node in the graph is a container, and each edge in the graph is permission to initiate connections. So 2 things I want you to notice about this graph. One, it's very difficult to understand, right? This thing's complicated. The code is not complicated, right? So we're just using the standard techniques of programming languages to hide complexity, right? Modules and functions and all these sorts of things allow us to get abstraction, which is a good thing, right? The second is this graph specifies exactly who's allowed to talk to who. So given that very strict communication specification, Quilt can automatically deploy it with a strict default deny firewall. So if a container attempts to initiate a connection that doesn't have a corresponding edge in this graph, Quilt will automatically drop the packets. OK, so to this point, I've discussed stitch specifications, application specification. I haven't talked about how you would actually deploy this. So to deploy this thing we've discussed, you have to also describe an infrastructure that it's going to run on. So let's have a look at what that would look like. So this is really it. It's pretty simple. This is an infrastructure that deploys the stitch specification on Amazon EC2 in Northern California with between 32 and 64 gigabytes of RAM and between 4 and 8 CPUs per VM. In line 5, we say there will be 3 of these virtual machines running as Quilt masters. These are going to run support services for our cluster. And 32 of these virtual machines running as Quilt workers. These are going to run the actual application containers. And if you remember earlier, I asked the question, how do you achieve portability? In Quilt, this is almost laughably trivial. If you'd like to run on Azure, you just run on Azure. It's straightforward. And if you're feeling adventurous, you can even do crazy things like geo-distribute across multiple cloud providers by organizing your application into little pods that can serve most traffic from cache but have a central database in Australia. And the stitch specification to do this looks right here. And the application is totally transparent. It just deploys and everything works, and it's great. Yeah. So that's sort of the motivating example of Quilt. I'm going to talk a little bit about the stitch specification language. Then I'll talk about the architecture of Quilt and a little bit of related work and future work. Yeah. So stitch is our specification language. It's a Lisp. It has all of the things you'd expect from a functional programming language: variables, arithmetic, functions, modules, etc. In addition to programming language stuff, it's got some demand-specific primitives for describing the communication graph of your application. So application-level primitives are shown here, the most important ones. The Docker function declares a Docker container should exist. The label function creates labeled sets of containers. The connect function says one label may initiate connections to another. And there's primitives for placement and setting environment variables within those containers. And then infrastructure primitive is the most important function, is the machine function, which declares a infrastructure VM should exist. And then you can configure it with its role within the cluster, the cloud provider it's going to run on, region, et cetera. So let me walk through another very simple Stitch example that will hopefully give you some intuition for how this fits together. So this is the Stitch specification for Apache Spark. Excuse me. In this first line, we declare there's a Docker container. It's going to run the Quilt Spark image. And we're going to label it Spark Master. In the second group of lines, there's a Docker container running Quilt Spark. There's 10 of them. And we're going to label them Spark Worker. Then we say, we use the connect function to say, Spark Masters and Spark Workers may initiate connections to Spark Workers on any port in the range 1,000 to 65,000. And Spark Workers may initiate connections to Spark Masters on port 7077. And one cool thing about the connect statement, it doesn't just open up firewall holes, but it also plays an important role in service discovery. So because of this last connect statement, all Spark workers are going to have a host name available to them, sparkmaster.di. And if they open a connection to that host name, Quilt will automatically route the traffic to a container labeled Spark Master. And we actually take advantage of this here, where we tell the Spark worker that the host name of its master is sparkmaster.di. When you run this through Quilt, Spark is a very simple system, so you get a very simple communication graph. So the Quilt architecture, how do we actually deploy these Stitch specifications? So this is an open source project we've been developing with the goals of being simple. The code's actually remarkably simple given what it's doing. Robust to failure, and portable. We want it to work across multiple cloud providers. So the architecture looks like this. There's an infrastructure controller whose role in the cluster is to create the infrastructure virtual machines that are going to run the application. And then there's the cluster, which has worker virtual machines that run the actual Docker containers, and Open vSwitch for an overlay, and master virtual machines which run an SDN controller and a placement scheduler. So let's have a look at the infrastructure controller. So the infrastructure controller, upon receiving a specification, passes it to a module called the engine. The engine executes the specification to generate the set of infrastructure machines that should exist. And then it writes it to a software library called the database. And then we have this software module called the cluster, which is the most interesting one. And what it does is it reads the set of virtual machines that should exist according to the specification from the database. And it reads the set of virtual machines that do exist in the cloud provider. And it computes a diff. And then it adds or deletes virtual machines as necessary to make the cloud provider in conformance with the spec. One really important aspect of the cluster is it has a pluggable interface. So you can add support for new cloud providers to it. Currently, we support Amazon EC2, Google Compute Engine, Microsoft Azure. And it's easy to add others. And let me actually show you what the plugin interface looks like. So Quilt's written in Go, so this is a Go interface. These are the set of functions that we have to implement to make a cloud provider work with Quilt. And it's pretty trivial stuff that all cloud providers can do: boot VMs, stop VMs, list the ones that are running, some basic network reachability. We just want to make sure the VMs can talk to each other. What's really important about this is it's completely agnostic to the application that you're running, right? It doesn't understand the Docker containers and the communication graph between them. It's just, how do I get up the appropriate VMs? And this is the key to our portability, because implementing very basic functionality across cloud provider is easy. Implementing very complicated functionality across cloud provider who all have different abstractions and everything is quite difficult. OK. So the cluster module creates a set of virtual machines that are going to run our application. These look like this. So the virtual machines run application containers and an SDN overlay. So the master nodes within the cluster run a controller that configure each worker virtual machine with the appropriate network ACLs to implement the communication graph. And then the worker virtual machines run the Docker containers that were specified, and then open vSwitch with an overlay to connect them. And again, what's important about this is it's completely infrastructure agnostic. So from the code's perspective that's running in the cluster, it just knows I have an IP address, my peers have IP addresses, and if I can reach those IP addresses, I can do the networking. It doesn't care what cloud provider everyone else is running on, what region of the world they're running on, anything like that. So that's the basic architecture. Before I move on, let me be very explicit about sort of unsolved problems in this project. Application configuration, so there's more to deploying an application than just booting containers and networking them. We allow you to configure the containers that you're going to run with command line arguments and environment variables, but I'd say at best it's inelegant. So that's a problem I'd like to solve in future work. There's a lot of concern in the broader community about container security. So there's a general feeling that virtual machines have better security properties than containers. We don't solve this problem at all. I'll point out that there's a lot of effort in the community to use things like unikernels to hopefully tighten down containers a little bit. And Quilt could work for scheduling virtual machines. So this is somewhat orthogonal to our project. There's more than network and compute in distributed systems. We also need a better way to think about state. We don't really handle that right now. And then external services. So you can connect Quilt deployments to the public internet, but we might want a first-class way to connect to certain cloud provider services like Amazon DynamoDB or something like that. Right now, that's just treated as an IP address on the public internet. Related work. There's a massive amount of related work. I'm not going to be comprehensive. I'm just going to try and touch on the stuff that might be going through your head right now really quickly. So there's a large number of container orchestrators, Kubernetes, Docker Swarm, Mesos, et cetera, et cetera, et cetera. So these systems provide a procedural interface to your cluster usually. So boot container, stop container. They aren't about declaring what containers should exist and then fixing up the state of the world so that it's true. They also don't understand the communication graph between containers, so they can't do this tight firewalling. The way to think of Quilt in relation to container orchestrators is it's a policy layer that sits above them. So we actually use Docker Swarm internally to make placement decisions about where to put containers. But the question of whether you should boot a container is Quilt's question. Docker Swarm is more about once you've decided to boot the container, where do I do it? There's also some sort of nascent work around specification of groups of containers to boot. Probably the best known in this space is Docker Compose. So these systems allow you to specify static serialization format, usually YAML. And you can say boot these 5 containers instead of booting 1 container at a time. Again, they don't understand the communication graph, so you can't do these sort of geo-distributed tight firewalling deployments that we do. And then the other issue is a little more subtle. So these static serialization formats aren't great for modularity. They don't have functions and modules and variables and all these sorts of things. So you don't really get that abstraction and data hiding that Quilt gives you. And in fact, if you'd like to deploy a system in a different context with more containers or in a slightly different manner, you have to actually edit the YAML files, which is a little bit ugly. Okay, future work. So this is a system we've built. It's an open source project. You can reach it at quilt.io. So there's going to be a lot of effort continuing in building this into something that's actually a production usable project, as is the tradition at Berkeley. From a research perspective, there's 2 areas I'm interested in. First, this idea that you should write down what your application should do. I think we can apply to other areas. So security policy is an interesting one. I want to write down who should have what private keys and what public keys should a particular service accept connections from, or what users should a particular service accept connections from. Policy around data. So I want to be able to say things like The customer service portal should only be allowed to access database replicas that contain data for users that have currently open help tickets, right? And that's sort of melding network and data policy. And then application configuration, I don't know how to solve this problem yet, but hopefully with sufficient effort I'll figure it out. Okay. The other area of future work that I'm actually extremely excited about from a research perspective is analysis, formal analysis of stitch specifications. So this is best described with an analogy. If you're trying to prove a property of a Go program, for example, it's much easier to deal with the Go source code than the x86 compiler output, right? But if you look at most of the research around network verification now, we're like pulling data from routing tables, right? Which can work, I guess, but it's going to be much easier to prove things like reachability by looking at the graph that Stitch outputs, right? It's just a simple graph algorithm. The other area I'm excited about is availability. So I want to say, prove that my system as deployed has 4 nines of availability, or deploy my system with enough redundancy that it has 4 nines of availability. Okay. So that's our system. Just in summary, Quilt is a portable application deployment system that provides strict network security. And it's based on Stitch, which is a declarative application specification language that allows you to do modular, shareable, and reusable specifications. From a research perspective, in future, I'm most excited about doing formal analysis of Stitch programs. And then from a practical perspective, this thing's available at quilt.io. It's sort of a pre-alpha release, but we're in the phase where it works, and we would love feedback in particular from people like you who have experience deploying systems. Oh, also feel free to contact me at this email, or if you go to quilt.io, you'll find my email on that page. Thank you very much.
Questions, please say your name and where you're coming from.
My name's Adam. I'm from Esri. We make geospatial software.
Yeah.
Is there any intersection with this and CNI or things like Project Calico or
So I don't know CNI. I know Calico.
container networking interface?
Oh, okay, yeah. So internally, to achieve the networking that I showed you, we use a network virtualization system that's sort of maybe a sibling to Calico called Open Virtual Network. So I would say the intersection is where a user of that sort of technology. Yeah, I think any sort of improvement in terms of container networking we'll be able to take advantage of, but we're sort of a layer on top of it. We aren't really competing with it. Yeah.
Other questions?
Oh, sorry.
Hey, Clay Benziger from Bloomberg.
Yeah.
Just a couple questions for you. The overlay networking. So I presume it's probably something like GRE tunnels and the like. And if so, just what's the performance impact of that?
Sure. So we're using. So this is a complex question. So we're using. So there's 2 options. We're using either VXLAN or SCT. SCT is, so I worked on Open vSwitch and Nicira before. SCT is this sort of like super hacky, scary tunneling protocol that has like really good performance. The performance impact, we measured it for the paper. I can give you exact numbers, but we're competitive to what native Docker gives you out of the box. Actually slightly, within measurement error, but slightly more performant because Open vSwitch is better optimized than the Linux networking stack that they're using. I would expect as time goes on and NICs get support for tunneling, better support for tunneling protocols, performance will improve too. Yeah.
Yeah, I wanted to ask why this master worker architecture, and why not if it is just matter of deployment, why not Ansible that you don't have workers, right?
So the reason we need this master node is it's actually running an SDN controller, so it's actually doing things at runtime. And my understanding of things like Chef and Ansible, they're more about getting a system configured initially, but they aren't going to do things like oh, this container went down, so I need to modify the OpenFlow tables on my particular Open vSwitch instance. So we had thought about using Ansible to do the sort of initial setup of the cluster of virtual machines. It hasn't been necessary so far just because the setup of the VMs is so trivial. We just run Docker. But it's something that we'd definitely look at in the future. Yeah.
Hi, my name's Aaron. I'm a Databricks trainer and also a DevOps engineer, so this is really fascinating.
Yeah.
Kind of a more practical question. Say someone who has, say, a set of Ansible playbooks that build up different node types. Okay,
Sure.
How would that be integrated into this? Is it pretty straightforward, or?
So I haven't thought about it at all. I don't know much about Ansible, so one piece of feedback I'm going to get is I'm going to go figure out how to integrate Ansible with this thing. My initial hunch, so we're just booting standard Docker containers, which look like Ubuntu images. So it seems to me that it'd be feasible if you have a bunch of Ansible playbooks to boot sort of bare Ubuntu images and then use Ansible to configure them to your liking. In sort of research land, that hasn't come up yet, but it sounds like that's something that would be interesting to people. Yeah. Yeah, sorry, waiting for the mic.
So it's more about usability and adoption, like more of a feature. Like, why do you pick Lisp as a so, and I was like, why do I need to write the main function? You sort of write the main function. Why can't I just write a YAML file and you run your engine to build everything? Why do I have to specify?
Yeah, sure.
the code for that?
Sure. So I'm going to give you the honest answer. So the reason it is written in Lisp is I'm a grad student. We don't have a lot of time. It was Christmas. I needed a syntax. Lisp is easy to implement. As the project matures, it's on the roadmap to come up with a syntax that's more familiar. Probably something Go-like or Python-like. The second question, sorry, why do I need to write that specification? So you minimally need to write enough specification to tell me the infrastructure you're running on. So if you're an Amazon shop, I need to know that.
So why can't I write the config file? YAML-based, just a config, right? Why do I write the sentence and connect this one to this one?
The difference between YAML and Stitch is Stitch is actually a programming language.
So you can, like a user can write the config file and Stitch can read this config file to probably generate this class.
Oh, sure. So you could imagine like a config file that says bootspark and a script that knows how to generate the appropriate stitch to bootspark from that. Yeah, the project's so new, I haven't thought about like tools sitting above Quilt that would make it even easier to use, but that's definitely something that we'd like to explore. Yeah.
Yeah, so thanks a lot. I have a question about monitoring.
Sure.
Once you use Stitch to deploy this thing, how do you know if things have failed, and how do you know if things are still up and running, so many days down the road, etc.?
Yeah. So this is also in the category of things that we're going to be addressing in the next couple months as we move from prototype to usable thing. So the Quilt master has a big opportunity to do some interesting monitoring things because it sees the entire cluster, the entire network, all of the containers running in the network. So we definitely like to export the ability to or have the ability to export information about what's currently running. In terms of like what happens now if a container fails, the Quilt master notices that it fails and restarts it. From an ops perspective, that's like far from ideal. We want more analytics around it, but it's just this is in the category of like solvable problems that we haven't gotten to yet, but are very high priority for us. Yeah.
Great. Let's give him a big hand.
All right. Thank you.
Thank you, Ethan.